Okay, welcome everybody. We'll just give it a few seconds more for some other people to join and then we'll start the webinar. Hopefully everyone can see the main slide. Okay, we'll make a start. So this webinar is an insight into hygienic process design for engineers across the brewing, food and beverage industry. Our chair in a minute will introduce everybody. My name is Richard Hellebrand and I'm volunteering for IMechE just to keep the IT side going. The event will be recorded, made available on the Process Industry Division YouTube playlist. We have disabled everyone's cameras and mics for a smoother presentation. Depending on your attendance duration, you'll get a CPD certificate after this. You also will get the slides as PDF. You can put your questions in the Q&A or the chat tabs, and we'll keep an eye on that. And our chair will go through those towards the end. I will, if I find chatbots AI, I will kick them out. That's a policy we have. Well, a little bit about Process Industry Division. We cover a lot of industries: bulk materials, food, drink, oil, gas, chemicals, pharma, oil and gas, water, wastewater, and other related areas. And we're a central point for mechanical engineers to connect in those industries and share expertise, promote best practices. I won't go through the whole slide. There is a QR code there, which you can scan if you want to go onto it. Again, it will be in the slides that you get afterwards. We are committed to equity, diversity and inclusion. We have a policy about that, but it isn't just a policy. It's not just words. We are very happy to engage with everybody, no matter what your race, your colour, your sexual orientation. We're all engineers. We're in this together. We should learn from each other and help each other. So it's very important. If you want to get involved with us, please let us know. And now I'll just hand over across to Martin Ralph, our chair, and he can introduce himself and the other people. Martin, over to you.
I can no longer unmute.
That's fine. I can hear you perfectly.
Okay, that's fine. Okay, good. So you unmuted me. Okay, so yeah, I'm Martin Ralph. I'm chair of the IMechE Food and Drink Engineering Division, and we've invited representatives from Briggs of Burton, a major OEM in the food and drink industry, and the University of Nottingham, who has a special brewing and food division. So they're all experts in their field. So I'd just like to introduce the main players here today. We've got Scott Davis, who's head of marketing at Briggs. He's going to chair the, if you like, the actual webinar. We've got, just reading a few notes here, which he's got over 2 decades of experience delivering. Sorry, that's the wrong person. Beg your pardon. Scott Davis is head of Briggs, head of marketing at Briggs. So over 12 years across marketing, business development, and sales, very much involved with STEM and engineering training. So he will be leading the webinar. The main speakers, we've got Rod White, who's assistant professor at the University of Nottingham in the brewing field. He was a master brewer with 20 years experience at Bass Brewers and Molson Coors. We've got Mike Sayer, and Mike has worked in the brewing industry for over 40 years in a variety of senior supply chain positions, ranging from craft beer operations to 6 billion hectolitre per annum breweries. Mike has recently joined the brewing team at the University of Nottingham with the aim of further nurturing his passion for beer brewing and for people development, and sharing his vast experience of the fantastic industry with young and aspiring brewers of the future. So that's good. We've also got 2 engineers from Briggs. Both of them are IMechE, therefore chartered engineers. And we have Steve Mason, who's a lead project manager It's over 15 years experience delivering hygienic process plants across brewing, distilling and food industry. And we have Rob Davis, who's a project engineering manager. Rob has over 2 decades of experience delivering hygienic process plants across brewing, distilling, food and pharmaceutical sectors. Chartered mechanical engineer and graduate of Loughborough University. So I think they're ideal people to give us a talk. I would say an itinerant brewery design engineer of designed breweries around the world. So and I'm just chairman. So there you go. We got a good list of people. So I'd now like to hand over to Scott Davis. So Scott, will you share your screen, please?
Yes, we will do. So just bear with us 1 second as we do that. Can I confirm this is seen by all, Martin? Can you see our screen and slides?
I can see it. I assume everyone else can see it.
Excellent. Thank you very much. Thank you very much for the introduction, Martin. We're obviously delighted to present to the IMechE. As you mentioned, we've got the University of Nottingham team, brewing team with us today, along with some engineers at Briggs. It's been really quite fun getting this group together to sort of pull this material together. I've learned a bit on the journey, and a big part of this, thinking about learning objectives, is around hygienic design. We thought the breweries and the stringency and the focus within that environment is a really good example. We thought for your benefit, we've got a mix of anecdotal, real-world evidence with a mix of theory. And our plans for this was to kind of engage you over lunchtimes for this webinar session and really working backwards. So we wanted to kind of get you into the mood of the perfect pint. And how does it get there? It doesn't just happen. You need the talented brewers and engineers to make that happen. So what we're going to do, we're going to work around the room, give you an account of some of our experiences and stories for the next 45 minutes or so. So what I'll do is I'll hand over to Rod.
Okay, thank you very much. So I'm going to kick off by just talking a little bit about what beer is and what it's made from. So beer is principally made from barley. And we're blessed in the UK. I know not everyone's from the UK on this call, but I think there are a lot of people from the UK. We have some of the best barley in the world. People seek it out from other countries, and that's partly due to our climate. And we take that barley and we make it into what we call malt. And that's the same malt that goes into malt whiskey. So there's a real sort of area of growing barley right the way down from sort of Aberdeen, Speyside, where the very expensive whiskies come from, all the way down to East Anglia and the south coast, is all next to the coast and makes incredibly good quality barley, which is converted into malt. We also use water, and traditionally Britain has had brewing centres that have grown up around famous sources of water. So we're sat in Burton-on-Trent, which is world famous for its water, the minerals within that water give beers certain qualities. And the water is different in Edinburgh and makes different styles of beers. The water in Dublin is different and makes other styles of beers. So it's very, very important what your water source is. We also add hops, which in the UK come from Kent and Worcester, but much more globally, they come from Germany and America and Australia and New Zealand. And we add those, but we add those in very small quantities. They are very much what we call the spice of brewing. So the amount that goes in would be more akin to the amount of basil and oregano you might add into your dinner this evening, as opposed to the spaghetti. It's added in very small quantities. And finally, we add yeast. We add one of two types of yeast. We can add ale yeast. And ale yeast has been around for millions and millions of years. It's been around since the sort of mists of time. Whereas lager yeast only sort of popped into existence about 400 years ago. And we possibly think that was linked to Columbus going over to America and some kind of interchange between yeasts from Europe mixing with other yeasts from South America, and they bred and popped lager. Lager is very, very different in terms of the yeast we use than ale. It's got a lot of genetic differences. And in terms of how we make beer, in the UK, beer is made, there are 7 very, very large breweries that may be about the size of sort of like an oil refinery in size, very, very big, complex sites. There's about 30 traditional breweries that would be, made much more with copper vessels and, beautiful old buildings. There's about 30 of them. And we're very blessed to have about 1,400 modern craft breweries that have emerged principally due to some changes in the legislation to do with beer tax about 20 years ago and led to an explosion of craft breweries. So we're a very, very vibrant scene split across these different types of breweries. Now, I just want to move on to my next slide, if I can make that work. We're going to actually work backwards through beer. So I'm actually starting with a pint in the pub. And one of the things we want to start by doing is talking about what's going on in a pub. And I'm actually going to train you a little bit in how to become expert buyers of beer. Hopefully something useful you can take away. Now, in a big brewery, we are in control of everything. We buy high quality equipment. We have stainless steel. We have high quality cleaning, automation, all of this technology and science in a brewery. And then we put it in a keg, and then we give it to a landlord. And he or she doesn't really have any training, puts it down some old plastic pipes that may or may not be cleaned. And basically, there's a large point in which it all goes wrong at this point. So I just want to bring that to life. And you can see some stats I have there on the screen. Something like 30% of pipes that we use to dispense beer are not clean. A lot of beer can be served too warm, and there's a lot of work around the glassware. And I've said, don't even get me started on Cask Beer Tuesdays. As I drove here today, there was a big sign up from a pub saying, come here on Tuesdays. And I've got some quotes from the internet. There's a pub, these were just randomly off Google. It says, join us at the Brass House every Tuesday and celebrate all things cask beer. And that was £3.25 a pint. There's another one from the People's Pub. Come and enjoy the authentic taste of the Cask Ale Club every Tuesday. My advice would be avoid that like the plague. What people do is they will open a cask on a Friday night when it's busy, try and sell it through on Saturday, hopefully finish it off on a Sunday. If they don't, they sell it off cheap on a Tuesday. And beer, it's very important we think of beer. Beer is essentially like bread. It's fresh, it's fresher the better. And cask beer in particular really shouldn't be on sale after the third day. So if you ever see cheap beer on a Tuesday, my advice would be avoid it like the plague. Okay. So forgive me, I'm pressing the wrong buttons.
Let's do previous now.
I'm trying to. It's like a hand-eye coordination test. There we are. It's going forwards and backwards.
You do it now.
That's all right. It's all right. It's all right. Forgive me. I'm back again. I'm in the room. Forgive me. And one of the things we found with pubs is there's a shocking correlation. What we've actually found is that landlords that clean their pipes once a week, which is recommended. So if you clean your pipes, we found this shocking correlation that you actually have clean pipes. If you actually go to the bother of cleaning them, you have clean pipes, and therefore you have clean beer. But lots of people try to extend how long they're going to clean their pipes for because it takes a lot of time. But this would be some of the classic faults we might see out in a pub. So you might go to a pub and have a complete flat pint, low foam. This is often caused by a dirty glass. It's particularly caused by, if you ever see people cleaning coffee cups in with the beer cup, in with the pint glasses, you get milk residues, and that builds up on the glassware and kills the pint. Another one you can get a smell that is reminiscent of butter. Some people call it Werther's Originals. And this comes when beer is sat in a pipe that's not clean. So if you have to watch brewers go into a quiet pub, they will often make sure they don't get the first pipe out of the lines. Sometimes the pint that sits in the lines can often have this buttery smell. So my advice is let your buddy go and get the first pint out, or you buy the round, give the pints out, make sure you get the third or fourth pint of the line, and you'll be good. Other problems we get is vinegar. Quite obvious when you get a vinegary pint. This is often due to dirty beer cellars. Remember that every time you pull a pint of beer out of, particularly a cask beer, you pull a pint of beer out, you pull a pint of air into that cask. And if that air is dirty, it can contain bacteria that will cause the beer to go vinegary. And then finally, how many of you have had a pint like that, where the bubbles all stick to the glass and people bang the pint on the table to try and jolly those bubbles along? Again, that's another example of a dirty glass. And I really think it's important that we all become better consumers and complaints, because we really do need to celebrate perfect beer. I've gone too far. I'm no good at this, forgive me. Stop. Here we are. Now, one of the reasons we have these problems is it's quite hard to clean a pipe in a pub. Some of you may be familiar with something called Sinner's Circle, and Sinner's Circle is the theoretical way in which you talk about cleaning of a pipe, whether that's in an oil refinery or a brewery or in a pub. And to get a good cleaning in a pipe, you need temperature, you need agitation, you need time, and you need chemicals. Now, if you've got a stainless steel pipe in a brewery, we do all that. But if you're in a plastic pint in a pub, we can't go to high temperatures because the plastic won't let you go to high temperatures. So we can't use temperature. When we put it into a pipe, it just sits in the pipe. We can't really get any agitation. So we've got no agitation. And we can't really give it any length of time. If you leave it in the pipe for more than about 2 hours, you can extract plasticizers and you get like what we call a chlorophenolic taint, which is like a TCP taste, which once led a student, I was talking about this to some of my brewing students, and they said, they put their hand in the air and they said, Rod, we don't really understand what TCP smells like because we weren't born in the 1980s. Which I thought was one of the single best things that ever come to me. And finally, the final slide I just want to talk about is the type of beer makes a huge difference. So some beers with strong alcohol are much, much more robust than beers without alcohol. There's currently, you might notice this, there's a lot of launches over this year of draft non-alcoholic beer, and there's an enormous problem. The problem is multiplied many-fold when you move to non-alcoholic products like this one I've got here, pictured here, Stella. And things like hops make a big difference. Hops are beer's natural preservatives. And traditionally, you've heard of people using the term IPA. IPA stands for India Pale Ale. And these were very heavily hopped beers that went out to India, and they had a certain preserved quality because of the high hop rates. And we have CO2, we have low pH. And also we have something I think is fascinating, we're only just starting to learn about, is some beers spoil a lot less than other beers. And we think what's leading this is there are actually a lot of the beer flavors in the flavors that we take out of a beer are actually signals, how yeast is signaling to other microorganisms. And some beer flavors can actually signal to bacteria to switch off and to go dormant. So there's a lot of complexity about how signaling and how some beers survive in pipes and other beers don't, which, yeah. So hopefully that's brought to life some of the issues you might find in trade. I'm now going to pass you on to my colleague, Mike, who's going to talk about some real life disasters that we've noticed in the brewery.
Yeah. Are you keeping hold of that?
I can do. I'm not very good at it.
Now you've perfected it.
I've not perfected it at all.
Okay, right. Well, thanks. Now we've had a sort of 10 minutes with Rod exploring the vagaries of the licensed trade. I'm stepping back inside the confines of the brewery, where you would expect, or at least hope, that brewers are in full control, or at least strongly influence what goes on. So I'm taking you back to a brewery I worked in, and the year is 1998. So apologies if you weren't around in 1998. But if you were, Tony Blair had just become Prime Minister. God bless him. David Beckham had been shown the red card in the World Cup, I think it was in France. And surprised when I Googled this, Wimbledon and Sheffield Wednesday were in the Premier League. But 1998, to me personally, forget all of that detail, really, is the year of the BAS International Product Recall. I'm going to talk to you now about the background to this incident, understand the impact of what can go wrong if we have sort of poor engineering governance and poor or negligible change management at play. So I was actually the quality manager at this brewery in Smethwick in the West Midlands in 1998. Next slide. There we go. Right, next slide, that's the one. So on the left-hand side, the widget beer was in growth. So widget beer was sort of pioneered and patented initially by Guinness, but in the mid-90s, all the competing breweries were basically getting in on the game. Widget beer, for those is still available in certain establishments, but basically it's beer that has liquid nitrogen added to it at the filler. It's generally found in keg or can, and I'm talking particularly about the can variant here. And to get the liquid nitrogen into the can, between the can being filled and the lid being seamed onto the can, the beer needs to be very, very cold, about 0 degrees C, if not colder. Then the liquid nitrogen stays on the surface of the beer before the lid is put on. The brewery in Smethwick, sadly, the beer was too warm, so we were having high losses and quality problems on the can filling lines. But no problem. We basically gave the engineering team the problem as the operations guys, and we said to the engineers, we need some heat exchangers installing, please, between our bulk tanks, which fed our 6 packaging lines, bottle and can, and we need to have our beer colder for packaging purposes, particularly for widgets. Our engineering colleagues took up that challenge, and over a long weekend installed a couple of plate heat exchangers, as shown a little graphic on the right hand side. Dead easy, 2 days work, came in on the Monday morning, and guess what, it worked an absolute treat. All the beer was being fed to our bottle and can fillers at 0 degrees C. Widget losses were reduced massively. Everybody was happy. What a great job done. High fives all round. Until about 8 weeks later, I received as quality manager, I tasted all the consumer complaints that came back in bottle and can. I'll never forget the moment. I basically opened this can of Carling, which was a 4% alcohol product, and we tasted it to see what the complainant was talking about. When she said it tasted sweet and deeply unpleasant, and one mouthful proved that she was absolutely correct. We spat out the offending product. Within half an hour, we had it analysed for alcohol, and it was found to be 2% alcohol in can. So, I'm not a mathematician, but very rapidly I realised it was 50% beer, 50% contaminant. So by the end of the day, we deduced what the contaminating agent was propylene glycol, which is a common secondary refrigerant used in the brewing industry. It circulates the tanks and heat exchangers to keep beer cold. So you can imagine, I don't know if some of you guys might have been involved in product recalls, but it is the absolute worst moment in your life. We knew there was 6 to 8 weeks of production out in the market. They'd been exported around Europe. Some of it had been exported to America. It was in bottle, it was in can, and we had absolutely no idea how much product was affected. So on the 3rd of July 1998, an international recall was announced. It was actually on the news at 9, for those old enough to remember. It wasn't news at 10 in those days, but 9 o'clock news, and it was headlines. And I was the quality manager. You can imagine where I was at. What is now called mental health point of view. It was pretty depressing, to say the least. Yeah, so as the screen shows, that the hit, the financial hit to the business from the recall was £12 million in the day. That's equivalent to £25 million today. Absolutely hit the bottom line, and 18% was wiped off our BAS shares, PLC shares, on the announcements of those end of year results, all on the back of a problem which was found to be, as this slide shows, a crack in the heat exchanger. So the heat exchangers that had been installed so successfully had been cracked. There was some welding burr, there was some welding debris left in the pipelines, in the mains. That got carried into the heat exchanger, which operated under high pressure. So that was the root cause, and the underlying cause was the fact that it was an installation root cause, but the underlying cause was a design issue. That on occasions, as the 6 filling lines stopped and started, the pressure on the glycol side of the heat exchanger on the plates was higher than the product side, which obviously then pushed the glycol into the beer. So we only ever got, so I can memory plays tricks, we got less than 20 complaints when we announced this recall. It was due diligence, it was food grade glycol, but from a due diligence brand protection point of view, we had to act. We couldn't leave the products out there. So I'm going to sort of hand over now to my colleagues at Briggs to talk a little bit about that sort of the good practice that actually kind of trying to alleviate this situation. Final slide, sorry, I've forgotten, but yeah, it's true to say 1990, this was a watershed moment for the brewing industry in the UK. If anybody had heard of Hassan, we certainly hadn't installed it on site. And if anybody had heard of sort of change management processes, nobody was executing effectively. It was a massive wake-up call, and a lot of competitor brewers have shaken my hand over the years and said, that could have been us. You know, thank you for taking it. Yeah, like a lot of mistakes, the industry learns and we move forward. Yeah. So the engineers are now going to talk a little bit about things are done properly.
Thanks, Mike. Yeah, so just wanted to take you through kind of the hygienic process design, focusing on design through to commissioning. It's not just the design stage that needs to be considered in this, and we're just going to cover now. So it's about getting things right from the start. Obviously, whether you're doing any project, whether it's a modification on site or it's a new build project, it's important to get things right. So starts probably with the P&ID, and then turning that kind of P&ID into a physical layout. That might be through a 3D model, ensuring that you get kind of the correct people in the room to do model reviews, because any poor designs or layouts could introduce the risks of kind of dead legs, poor drainage, maybe hard to clean areas in the plant. And then the other thing is, as part of the design stage, is making sure that the equipment selection is right. So not just the equipment, but also kind of the pipework specification. Equipment. So, for example, you can see on the picture, you've got some hygienic butterfly valves in there. So, making sure that the valve selection is correct. Steve's going to talk to you about a bit more about kind of double seat valves in his stage coming up after this. The other thing, like I mentioned, is making sure that your pipework specification is correct. So, making sure that the right material for the product that's going through the pipe is selected. So, for example, we might use 316 pipework on hot water and CIP. And so what I've just talked about really is what we call the DQ stage, the design qualification, and that's really the critical part to get right, to make sure that the hygienic design is correct to start with. Having said that, even with the correct design and equipment selection, it can be compromised if the installation on site is poor. So really critical to select the right contractor who's got the relevant experience and qualifications to complete the work. Really critical again to use qualified welders, making sure that welds are prepped, purged, inspected, and ensure that you've got the correct penetration and quality on the welds as part of the installation. Sorry, next slide. So following the installation, we've obviously got the commissioning stage, the CQV stage, so commissioning, qualification and validation. This is made up of kind of 3 steps. So you've got installation qualification to ensure that the installation is installed as designed. OQ, which is the sequence testing and with water, and then PQ, which is your performance qualification, which is making sure that when you're actually making products. Briggs use kind of app-driven phase gate system, which you can kind of see on the side. So we break it down into different phase gates. So phase gate A is part of the IQ, your installation qualification. So that at that point you'll be checking that stuff is installed as designed, redlining P&IDs against the installation to ensure it's all correctly installed. Once you've checked that it's installed correctly, power and compressed air will then be switched on, and you go into phase gate B, which would be electrical checks and IO checking, making sure that stuff's operating as it should. And then we will then go into phase gate C, which would be water flushing and leak testing. And that will be kind of part of your IQ then signed off, work then through to OQ, doing sequence testing with water, making sure the system's operating as it should. And then obviously before you then go into the final product trials, you do a full CIP on the system as well. It's, as kind of Mike's story shows, it's really important that these steps are done in a logical or a structured approach, which will reduce the risk of any problems going forward. And then post that, once you are making product and the clients are making product, there's also the kind of regular audit and maintenance side of things, where O&Ms can help support kind of ensuring that the system is operating as it should, and being maintained to ensure that you're not getting any damaged equipment, compromising any seals or any contamination in the system. So I'll hand over to Steve now, just to take you into a bit more detail on a few of those areas.
Yeah, so just taking it a step further into equipment selection. So as Rob referred earlier, you've got to make sure for a hygienic application that you've got the right equipment in the area. And for this example, we're going to look at a focus on valve matrices. They do form quite a large part of a hygienic process installation, particularly in a brewery cold block. For those that don't know, brewery cold block is where all the fermentation, maturation, finishing of the beer takes place. So it's go back to Rod's point, it's a very critical part of the process to maintain the quality of the product going out the door. Valve matrices typically used for segregating different product streams, segregating CIP streams, etc. And as with most walks of life and most pieces of equipment, there are differing specifications, different levels of functionality that you can specify on these valves, and I'll take you through some of those just now. It's not all about choosing the right specification of equipment either. There's also needs to be a consideration to layout, to support maintenance, to support cleanliness of the plant. And in the case of large valve matrices, you also need to consider thermal expansion when you're looking at hot CIPs and things along those lines. So there's a lot of considerations there, and I'll take you through some of those layout considerations. So just an example here of some different specifications of valves dependent upon the level of hygiene that you require within that piece of equipment. So the focus here is on the I don't know, probably can't see my cursor. You can there. This sealing face just here. In this application, this is just a seat clean valve, sometimes called, where when they go into CIP, the line CIP actually then cleans that face. You can then take it a step further, where you can get a seat lift valve, where you have the ability to maintain a separate product stream and CIP stream, whilst also cleaning the lower line, and also this leakage path as you see here, and this sealing face here. So that takes you another level and essentially adds a little bit more hygiene into this into the leakage chamber part of the valve as well, such that you can't get any infection coming up the way into the valve. And then you can also go a step further again and look at cleaning of the actual actuator shaft area and the leakage chamber completely separately to the line clean, as you see there, with that external flushing ability. And the general principle is that as you increase the functionality on the valve, the level of hygiene increases, assuming that the plant has been commissioned and validated, and the operation of the plant's been validated during a commissioning process, as Rob's referred. As I say, it's not all about choosing the right specification of equipment, whilst that forms a very big part of it. Another large part is how you actually lay the plant out. I think it'd be fair to say that there's more delay incurred and probably a reluctance to maintain equipment if it's more difficult to access, and that's just human nature. Typically, in these valve manifold applications, we would have access platforms between banks of valves, as you see there. That helps facilitate the safe egress of the valve insert for maintenance and changing of seals and things along those lines. The same can be said for a lot of process hygiene, process equipment, and maintenance platforms included as part of the design. That's not to say that you have to have a fixed platform for every part of a process install, but you need to put consideration to that. If you're going to get a mobile tower or a MUPE or something into that area, that it is accessible. Again, if you can only access a piece of equipment by a fixed scaffold, there's going to be a delay in terms of maintaining a valve seal or an agitator seal or things along those lines. You also need to consider the cleanliness of the building, the facility in which the process plant sits. You need to make consideration to, can you get underneath these valve matrices? Are you able to get a mop under there? Are you able to get a pressure washer under there, a squeegee under there to get the excess water away? So that needs consideration. And also access around the plant, so it's easy to clean around the valve matrices. It's not butt up against a wall. And again, going back to Rob's point there, you could have the correct equipment, you could have the layout absolutely perfect, but unless you validated the operation of the plant, unless you validated the seat lift timers, you validated the drain down timers and things like that during a validation step, the equipment's only as good as how it's operated ultimately, which I think leads me neatly on to Mike's next story.
Okay, I'm going to pass the dude for over. Thank you. Cheers, Dave. Okay, so this is the final section, and again we're back to sort of real life in the brewery. So this is another phase of my colourful brewing life. I was actually a head brewer down at the Hancock's Brewery down in Cardiff, for those that may know it. My Cardiff station. It was a very traditional site at the time, and it brewed beers for Wales and for the southwest of England. Very traditional, a lot of cask beer and a lot of keg beer, so no bottles cans. And cask beer, as Rod White started to talk sort of 20 minutes ago, half an hour ago, it is fantastic. At its best, cask beer, for me, you can't beat it. However, it is an inherently unstable product. It's unpasteurised, it's unfiltered, and it is prone to infection. So if the hygiene through the production process and through the dispense process is not good enough, then the product will spoil. Beer is a lovely medium for microbes. They love it. It's full of sugars and amino acids and vitamins and minerals, and it's good for humans in moderation. It's also enjoyed by sort of smaller critters, which are beer spoilage bacteria. And not surprisingly, but in the summer months when the sun actually does shine, even in Wales on occasions, and the temperature soars up to about 20 degrees C, then these bugs, these beer spoilage bugs, they like life even better, because the higher the temperature, the faster the rate of reaction, the faster the spoilage. And Hancock's Brewery, when I went down there, had a tradition in the summer. It was renowned that cask beer quality went downhill in the summer. So my job was to manage that operation through the teams there and through capital investment. So yeah, this is just a picture of cask beer. I guess some of you may not be aware, but cask beer is filled pretty manually. The picture on the left is literally sort of guys filling containers. This isn't Hancock's, but it's a typical manual filling operation. Lots of airborne bugs floating around, and you can see the operators there have got gloves on, and hopefully it's a hygienic environment as possible. And if beer does become infected, then it goes from a nice, clear, tasty product to a hazy, ropey, foul-tasting product, as Rod White described earlier. So suffice to say, I was there my first summer. We started getting cask beer returns. So you always get a very small amount of returns from pubs, mainly because they're overstocked, I would hasten to add, as a brewer. But on this occasion, it was a verified. We had beer spoilage in trade, and our cask beer started to return at a fairly uneconomic rate, and things were problematic. The brewery, I should say at this stage that the brewery had actually been subject to quite a lot of capital investment in the years before I arrived on the site. And as Steve was just talking, Cardiff Brewery had a beautiful installation of double seat routing valves. So the brewery had moved away from more traditional routing through flexible rubber hoses or through swing bend panels or change hand stations, as you might know them. And we had a beautiful capital investment. Excellent, less manning, lower beer losses, better oxygen control, and obviously better hygiene. Or not? Question mark. In theory, yes. In practice, no. So one of the things I did, we did a sort of root and branch problem-solving exercise on the site. We had to get to the bottom of this infection. It was hurting us financially, but also the brand, the brand kudos in trade was in danger of being impacted this particular summer. So we did a deep dive. I asked the engineering guys, the engineering team on site to break down some of these valve bodies that had been installed the previous year. And they did. So literally we took the tops off, we disconnected the electrics and the pneumatics, and we took the valves apart in situ. And it was a pretty sobering moment, because what we found was that whilst the design was correct, the valves had been correctly specified. So we had the ultra hygienic valves that Steve's just been talking about, with external seat cleaning operation. So the specification was correct, but what was incorrect was the install / commissioning. Because on occasion we found a number of these valves that had never had the seat cleaning valves properly commissioned and set up. So we either had no cleaning flow through the central shaft and the leakage chamber, or if we did, it was insufficient. The beer would then end up on the floor, and as Steve was saying, the finishes, the brewery finishes, the hygienic finishes are absolutely critical. What we found was we had beer residues on the floor, we had bacteria, obviously, but even worse, we had flies feeding on the beer residues on the floor, and they would seek shelter inside the valve body. I couldn't believe it until I saw it with my own eyes. The flies would go up through the leakage chamber into the nice, warm, cosy confines of the leakage chamber in the middle of the valve, and we found, evidence of fly and maggots infestation. And it's hard, it's pretty quickly saying there's a fundamental problem here. So what for me, obviously, we got to the root cause, but for me there was a number of things at play here. So correctly installed, correctly specified valves, yeah, that's correct. But the whole commissioning CQV commissioning, qualification and validation process had broken down. These things hadn't been commissioned properly. These things hadn't been water tested, and they hadn't been product tested because they'd never been cleaned properly. And I think the big takeaway for me, as a younger man in those days, and the top picture is meant to depict people training. What we've done here, yes, okay, the root cause was poor installation in CQV, but also the people on the site, the operations guys, and that critical interface between engineering teams and operations teams during any project on site. That interface was not well founded. And the guys on site who had been used to sort of manual routing, hoses, swing bend stations, nobody had taken them on an educational journey through automation, through double seat valve operation, what it meant, how it should all work. The guys were basically left in the dark. They were ignorant, but not of their own volition. So I think all I'm trying to call out here is that the relationship between engineering teams and operational teams is critical, but also the communication of every stage of that journey, from design through P&IDs get the guys involved, educate them through the route. And you may well do this. You know, I'm going back a number of years here. I know things have improved, but taking your operators and your teams on the journey through the design, through to installation, that sense of ownership is absolutely critical. Yeah. I think, yeah, I'm going to hand over. That's the end of the horror stories from me. And I'm going to hand you on to Scott now, who isn't a horror story at all.
Yeah.
So there we go.
So massive thank you for listening, team. Hopefully you've enjoyed the balance between some real world stories and some delivery on the projects the team are doing. It's good practice, and hopefully we've satisfied the learning objectives of raising your awareness about the impact of hygienic design in the real world. And if people have any follow-ups, we've listed our emails there. Rod and I have had some chats recently about the value of this type of content or training. So if you think there's more interest in hygienic design, we've also done some great relation and training alongside Briggs and University for lockout, tagout. So we've been working with the university because they are experts in training. We've got a lot of expertise in engineering know-how, and we've found that partnership really quite successful over the last year. And we'd like to spread the word probably on that. So if people have some questions around training operators or team members around hygienic design or lockout, tagout, please do drop myself or Rod an email. And any time that we want to host people, the pilot brewery that Briggs built for the University of Nottingham is open and available, and a really nice asset and a scale of operations to get hands-on and see. So if the IMechE would like to visit that, then the doors are well open to come and have a look and see some of the hygienic design considerations in the real world and in practice. So over to the IMechE and Martin, and thank you very much on behalf of this team and for them giving their time to deliver this. So thanks for having us. We'll be more than happy to take questions. Yeah, so over to the IMechE.
Okay. Well, thanks very much. I hope everyone can hear me. Thank you. We have one question, and if you don't mind, and a statement, but the one question is, why wasn't the secondary loop installed with water cooling for the glycol problem? I hear a lot of heat exchangers leak. Can I just put my 5 pence in if I can? Sorry about this, but you know, I've come across this problem more than one side. It isn't just Bass; it's everywhere in the world has this problem. And at the time, in the 1980s, 1990s, most people did very little about it apart from repair the heat exchanger. But what came after this, when everyone realised how much a recall costs, certain rules were put in place. For example, water is still a contaminant. Whether you've got water in there or not, you know, if you've got glycol or water, it's still a contaminant, and no one wants a 50% water mix in their beer, rather than glycol. So, and the real problem there is you can't tell it. If it's glycol, you can tell by the taste. If it's water, it just tastes like weak beer. So what we did at the time was we started putting dye in the glycol. You could have red dye, and therefore your beer would end up having a red tinge to it. But because of these big vessels we have in breweries, we could have, you know, loads and loads of pints of beer in a tank, you know, sort of 5,000 hectolitres of beer contaminated. You want not to have that. That's just wasted. So lots of people put in pressure testing requirements into their specification. So on a regular basis, you would pressure test your plate exchanger. That's great. It's good. But it still won't stop contamination. So we looked at making sure that the product side pressure was higher than the coolant side. So if you had a leak, it would go from the high pressure side to the low pressure side. But that doesn't always work. You still get some leakage back again. So I think the best thing is that you take all these things into account. There are things on the market now for regular testing, continuous testing of pressure testing of equipment, and therefore it can tell you pretty quickly if you've got a leak. You could, and maintenance and things like that are also obviously critical. I mean, I'll hand that back to you. Is there anything else the panel thinks should be added to that?
around the table?
Yeah, thanks, Martin. So if I understand the question, is this to do with how we can design out to avoid the problem?
What specifically it said, could we use a water cooling loop between the glycol and the product?
Yeah. Well, I think you've answered that. That any contamination of the product is undesirable for them. I think you've covered that. So and I think you've covered most salient points there, Martin. But yeah, there was lots and lots of different design steps put in, keeping the product pressure on a higher pressure at all times than the coolant. So whatever's on the other side of the plates, whether it be steam, cold water, hot water, glycol, the product pressure should always be higher, so that if the worst does happen, these plates are millimeters thick. It is always a risk, but at least you get movement of the product into the utility media rather than vice versa. And the other one is checking. So it is a critical control point on all of our heat exchangers on site. So we do have manual checks every half hour. Guys will check and they write down visually on paper or onto the PLC onto the control screen that what that temperature, what the pressure of the product is and what the pressure of the glycol is. So there's traceability. We'll look every half hour. So if we see any movement, any trends, we can spot it and we can isolate that the period of that problem. Sorry, Rob.
I think just the wider point for me is, I know there's people from different countries, different industries, is to really think about HAZAP. If you're not familiar with HAZAP or those risk management approaches, I work a lot in America, and HAZAP has got nowhere near the same kind of emphasis as it does in the UK because of this incident. This incident really did spark a revolution in our industry, but there will be other industries that are waiting to have their disaster. So maybe some of you from other industries could really think about that and say, is there a disaster coming down the line that I'm not fully prepared for? And maybe you can avoid something happening to you.
Sure.
Any other questions from there's 50 of you on there? I'm sure you've got lots of questions. 78 people now.
There's one here. Is there cross training and sharing with other food and drink sectors? Perhaps you could recommend a website or resource.
Oh, that's a good point. I don't think we're very good at that. I think the brewing industry doesn't really even look to the distilling industry that much. I mean, Briggs across both camps. But we would never really speak. I personally wouldn't. But people like Briggs who cross different industries might be better at answering that. But as an industry, we are quite insular, which is probably something we ought to think about.
Briggs. I would just add to that and say that Briggs we're incredibly open, so we're very happy to talk and share. But whether the correct forums exist, as Rod's just said, is a question mark.
Yeah, I think it's a fair point.
I think that's part of the closing remarks, really, is we recognise through this process, this is an operation engineering discussion. It's been quite fruitful, but you've got a strong track record of teaching a whole mix of brewers. And we were kind of reflecting, what about food operators? What about the food industry and the wider beverage industry? So I think there's a lot of know-how, but we're not quite clear on the forums. And part of our discussion, Rod, is how does that exist? We've got a pilot brewery, but it is effectively a food factory. It's got a PLC, it's got some hygienic, it's got some vessels that heats and cools. So if we stand back and say it is a 10 hectolitre brewery and we just said it's a food factory, we'd be super keen for, as part of our collaboration, to get people in there, to train them, whether that be remotely because of the geographical reach in this, or physically doing some day training. We've used that asset at 10 hectolitre brewery with some of our own team members with hygienic design, some brewing know-how, and lockout tag out. So we don't think it exists, and I think we'd like to explore further whether there is value. So as I said before, if people have that as a gap and they want us to fill that gap, then please do reach out, because we've got some ideas on the access to the know-how and the delivery of that. So that's our read and position at the moment. So
yeah,
I think it is good to talk.
So questions on a postcard, please. If you send in your questions, we can maybe cover it as a future webinar. But I think you're right. I mean, I've worked in the food industry as well as brewing, and I find the skills you learn in brewing are very, very useful in other industries like the food industry and pharmaceuticals and toiletries. And I've even things like polymers, where they want very high quality polymer to paint an airplane. They've found that the hygiene skills you learn in breweries transfer across quite well. And I think this is quite a good sector to work in. Right, what else we got here? I've got one here which says, as an early career process engineer and keen home brewer, I'm exploring careers in the brewing and beverage industry. Do you have any advice for breaking into this sector, e.g. transferable skills to emphasize certification needed, etc.? I mean, apart from joining the Institute of Chartered Institute of Brewers and Distillers, I don't know what else to say there. Have you got comments there? How do youngsters break into this?
Well, I think this is an area myself and Rod are both passionate about, hence our move into the education post our brewing careers. I think the easiest thing to do would be to pass Rod or my email address on to the individual, okay. and we can take that offline. So it's something I'm passionate. In fact, only yesterday I had a half-hour call with a guy that I've met through the university about career development in the industry. It's something that I do, and Rod does every week.
Yes, come and do a brew day with us at the university.
Yeah.
We do. We also run an apprenticeship program which you could get involved in and sit at the back of the class and get to see a bit more about brewing, get to meet a few people, and we can direct you. The brewing industry really has the brewing industry in the UK is sort of split into kind of three kind of groups. You've got like multinationals, which is a very different world, but very big breweries, traditional world, and then you've got the craft world. So you'd have to pick which part of the industry you wanted to dip your toe into. But come for a brew day or come and meet with us, and we'll do our best to help you.
Just pass our email addresses on, Martin, and
Rod's is on the slide back. I mean, if you just put yours, I mean, if you just exchange Rod White for mike.sayer@nottinghamac.uk, it'll get through to you. So
yeah, absolutely.
Okay, so they're in the slide pack when you get the slide pack. Okay, so is there anything else? I'm just going between chat and Q&A. Someone did Nick Jones. I recognise Nick Jones. Very famous in the industry. Water would freeze. This is referring back to the glycol. Yeah, it would freeze at below zero, obviously, but and that has happened. So yes, it's another point to the list of things not to do. I've got something here which is a nice statement. It says, fascinating. As a humble project man in pubs 15 to 20 years ago, trained to check beer quality by Edward Theakston, I never realised brewery kit was so complex. Thank you. So maybe it wasn't Theakston, so I can't remember. Sorry.
We've turned a very simple process into a very complicated.
Yeah.
It's an art.
It is, yeah. It is an art. When when you're brewing 6 million hectolitres per annum, it's quite different, isn't it? So
that's the difficult bit, the consistency and making money at the hard bits.
Yeah. Yeah. I mean, I've built design breweries in Africa and places like this, and the care you have to take is when you're talking about very high temperature environments, and basically at altitude, for example, where your boiling point is 92 degrees Celsius, you got more risk from bugs at that end. So it's horses for courses. So you've got to know what your environment is and then design accordingly. So
it's a very good point, Sam, you made there, Martin. Is one of the problems we have in this country is the breweries are all from a lot of them were designed in the 1970s by very skilled people, probably yourself. But when they were designed, no one could envisage the temperature in the UK being higher than about 32 centigrade. It's just inconceivable that British weather would ever be higher than 32 centigrade. But it was only a couple of summers ago, it went to 40. And you phone around the breweries the following week after that 40 degrees, and everybody was utter chaos because nothing was designed to cope with anything above 30 degrees centigrade in the UK.
And I think terrible on that point is the things we design today have decades of tenure ahead of them. We'll post 2030 world sustainability net zero targets. So what will the climate be, and are we ready for it? So it's a big part of what you design today for the future.
Can I just interrupt? We're just about at the hour. There was one other question as well from Finlay Underhill. How are breweries typically powered?
I mean, my comment is that if you take a city and how you power a city, most big breweries are the same. You know, you have generators, you have boilers, you have all sorts of things. So, steam driven is most of the hot processes are steam driven, and you require obviously oil or some fossil fuel to produce the steam, and electricity for everything else. And anyone else got any comments on that?
No, that's about it. Yeah, it's pretty traditional. Yeah,
It's clearly changing a lot. I mean, there's a lot. It's a huge question, and that would make a very, very interesting further session. Is where we're going, because Briggs are experts in that. But there's been some huge investments recently to go to net zero. But again, I think it would be fascinating to know what we're doing in brewing, which has spent a huge amount of money. But I'd love to know what parallel industries are doing. So that would be a fascinating another debate for another day.
Out of interest as well, sorry, Martin, we're also running a separate series of webinars with IChemE about climate change adaptation. Now, it's targeted at hazardous industries, but we didn't think about brewing and food. So maybe that's something we need to rope in and think about. I just conscious it's gone past the hour. Okay. So unless anybody's got anything else, can I just suggest I wrap it up?
Well, can we go on to the final slides, please? Can you put me back?
Yeah, absolutely. So that's the finals. There you go.
Guys, this is our, we record our webinars, and eventually you'll find this session on a recording. So when you get the slide pack, you'll see how to actually go about that. So can you go on to the next one, which I believe is quite relevant to what was just talked about. So this is coming up soon, 11th of December. Heat pumps, integrating heat pumps in the process systems. I mean, this again is as Richard said, is aimed at all industries, all process industries, including the food and drink industry. So it's worth coming along. I know Briggs are very much into heat pumps. So I think this good. Then following slide, I think it's just a wind up in wind up slide. If you go to the next one. Okay, this is us. This is IMechE. We very much, this year we've run 26 webinars across the process industries division. I think they're very useful, and all it leaves for me to do is say thank you to all of our presenters today. I think it's a very interesting talk, and maybe there's room in the future for more such talks. Thanks very much.
Absolutely.
Absolute pleasure. Thanks.
Thank you. Cheers.
Thank you.
Thank you.
Okay.
Cheers, bye-bye.
Thanks very much then, and
Cheers.
I'll leave it to you, Richard, to